Hello everyone. In this, welcome to Engineering Mechanics. In this video, I would like to tell you about the uh, finding the moment of inertia of a rectangle section. Okay, for rectangle cross section, how to find out the moment of inertia. Now we are going to discuss. So the question I would like to give like find the moment of inertia of rectangle. So for that I want to assume a rectangle shape, that is the section rectangular section sectional plane. Okay, so with respect to x and y axis, so I want to assume the width as b and the depth as d. Okay, width is b and depth is d for this rectangular section. Okay, next again I want to consider a small elemental area of dy height and area dA. Okay, and at a distance of y from the x axis. Okay, initially we'll be assuming small elemental area. So by for this elemental area, first we try to find out the moment of inertia, then we find the moment of inertia for the entire body. So for that purpose I have taken small elemental area dA of height dy, which is at a distance of y from the x axis. Okay, so first I would like to find the moment of inertia about x axis, because this area we have assumed with respect to the x axis only. Okay, so now the moment of inertia about x axis already we have discussed in the previous video tutorial, as it can be written as with respect to x axis as integral y square dA. Okay, integral y square dA, we can write it as y is the distance of that particular area from the axis with which it can cause the angular acceleration or rotation of the body. Okay, so first I would like to write dA, the area I want to find out for this elemental area we have assumed dA. So that dA is equal to, can be written as, which is also in a shape of rectangle only. Okay, rectangle area is depth into width. Okay, so that can be written as b into height or depth we have taken as dy for that particular elemental area. So the area of this elemental area dA can be written as whatever the height dy or that is depth dy into breadth or width is the b, we can write it. So b into dy is the area of this elemental area. Okay, so next the y is equal to, which is the distance of that elemental area up to the middle line. So here I forgot to mention, so up to the middle line, that means up to the center position of this elemental area we need to take the distance. So that distance we can assume as a y. So y is equal to automatically y. Okay, so next again ixx can be modified as, that is the moment of inertia about x axis can be modified as integration y square is as it is y square, and in place of dA, sorry, next step I would like to write that. So integral y square into dA, in place of dA we can write it as b into dy, b into dy we can write it as. So in this equation I would like to take the b as common. So take the b as common, write it as b into, sorry, integral b into integral y square dy, we can write it as. Okay, so next we go for finding the limits. So the limits we can take below and above the x-axis, because we have taken the area with respect to x-axis, we are finding the moment of inertia also with respect to x-axis only. So the limits we have to take from below dimensional value to the above dimensional value, which can be taken as the below x-axis is a negative, the dimensional value is whole is d. So below the value half of the d will be there, so half of the d by 2, so minus d by 2, this one is also half distance, which will be again d by 2, that is positive d by 2 above x-axis. So that the limits can be taken as minus d by 2 below axis dimensional value to d by 2 positive d by 2 above the x-axis dimensional value. Okay, these are the limits we can consider for finding the moment of inertia of whole body. Okay, that limits we apply to the equation. So ixx is equal to, we can write it as b into integration minus d by 2 to plus d by 2 into y square dy, we can write it as the equation. So that equation again we can write it as by applying the integration b into y cube, the integral y square dy or integral x square dy means, if you know that integral of x power n is equal to the formula is x power n plus 1 by n plus 1. So similarly y power 2 plus 1 by 2 plus 1 will be getting, so automatically y cube by 3 will be getting the integration of the y square dy, and the limits we can represent like with square brackets minus d by 2 below to the plus d by 2 above we can represent. So now we would like to apply these limiting values. Okay, how can we apply? Means this value substituting in place of y minus this bottom limit value substituting at the place of the y. So how can we represent? Means b into d by 2 whole cube by 3 minus d by 2 whole cube by 3. Okay, this is the procedure of applying the limits to the equation. So now by modifying this equation, the same equation I have written here, so how can we modify? Means 2 cube is the 8, so we can write it as d cube by 8 into 3 we can write it as. Similarly minus here minus cube is there, so even it is a minus cube we'll be getting minus only, so I didn't write it as minus d whole cube by 2 cube means 8, so again we can write it as 3 into 8. Okay, next in the next step we can write it as positive y positive means here minus d is there, so minus cube means again minus will be getting outside of the d, so minus into minus again it becomes a plus. Okay, so then d cube by 3 into 8 plus d cube by 3 into 8 will be getting, so both are same values. Positive means we need to sum, add the value, add the equation, so we can write it as b into 2 into d cube by 3 into 8. So when you consider 2 4 ja we can cancel, so 2 4 ja will be getting, so 4 into 3 remaining is 12. So finally we can write the equation that is the moment of inertia but x-axis is equal to b, this is b into d cube by 3 into 4 12. Okay, this is the final equation for finding the moment of inertia of rectangle section about x-axis. So when you consider the y-axis, these two values will be interchanged. db cube by 12 will be getting for moment of inertia about y axis. So once we find the moment of inertia about x-axis for any particular section, we can easily write the moment of inertia of that particular section with respect to y-axis. So this is the equation with respect to x-axis. Similarly with respect to y-axis we can write it as in opposite, db cube by 12. Okay, so this is the final equation we'll be getting for finding the moment of inertia of rectangular section. Okay, I hope you understand, and if you still have any doubts please feel free to give a comment to my video so that I'll try to clarify your doubts. And once again thanks for watching my video, and please share and subscribe to my channel, and so that's it. Thank you all.